Good afternoon, teachers. Good afternoon, grade 12 learners. My name is Mohapi. I'm going to take you through some few exercises on Euclidean geometry to try and prepare thoroughly for this topic. Remember, this is the topic that takes about 50 marks in paper 2. And remember, paper 2 will be written on the 3rd of November. On the 3rd of November, grade 12 learners will be sitting for the final examination on paper 2, mathematics paper 2. Thank you. Without any waste of time, let me take you through some few exercises just to make sure that I refresh your mind on the application of all the geometric theorems. We've done lots and lots of theorems. I think now what we need to do is just to put them into practice, because I believe once you practice them all, then everything will become easy, and you as learners will also be familiar with the theorems. Let me take you through the first exercise. Thank you. If you can check in there, we've got the question. Let's analyze the question. From my previous presentations, I've always been emphasizing the importance of analyzing the given statement. Once you analyze the given statement, whatever information that you pick up, you immediately indicate that information on the diagram. That is the accompanying diagram. Thank you. Let's go. In the diagram alongside, AB is a chord. You look for AB. Here is AB. AB is a chord of a circle with center O, meaning that O is the center of the circle. ON is perpendicular to AB. Look at ON. ON perpendicular to AB at M. I think we can all see that, and that angle is already marked 90 degrees. MN is 30 millimeters. We go to MN. Check MN. This MN is 30 millimeters. Immediately, you mark it on the diagram to know that MN is 30 millimeters. And the radius of the circle is 150 millimeters. What is the radius? A line from the center to the circumference. Here is the radius. OA is the radius. OB is also the radius. ON is also the radius. So radius is 150 millimeters. This radius is 150 millimeters. All the information that you have, you immediately mark it on the diagram. The question states, calculate with reasons the length of AB. The length of AB. Thank you. Let's analyze. Remember what is given. Radius is 150 millimeters. Check. OA is 150. ON is 150. Look at ON. ON is equals to 150 millimeters because ON is the radius. But if we can check, ON is divided into two. ON is divided into OM plus MN. They must give us 150. Check. OM plus MN, they should give us 150. So we can work out the length of OM. Therefore, it means OM plus MN, check MN, is given as 30 millimeters, which is equal to 150 millimeters. Therefore, OM will then be equal to 150 minus 30, which will give us 120 millimeters. That is the length of OM. So we come here, this one is 100 OM. What is OM? OM is 120 millimeters. That's OM. So let's go through the questions. The question is, we've calculated with reasons the length of AB. The length of AB. Now that we've got OM as 120, it's easy for us to calculate AM. According to Pythagoras' theorem, OA squared is equals to OA squared is equals to OM squared plus MAM squared. This is according to Pythagoras' theorem. Pythagoras' theorem. Now let's substitute. OA, look at OO, it's 150. You square it. OM is 120. You square it. AM is our unknown. We want to determine the length of AM. So let's square 150 with the aid of a calculator. Work it out. 150, you square it. I think 150 squared will give you 22,500. 22,500, which is equal to 120. Let's check 120. What is, when you square it, what will be the value? 120, when you square it, you've got 14,400. This one gives us 14,400 plus AM squared. Now it becomes easy for us to determine the length of AM squared. We group the like terms. You transpose 14,400, you transpose to the left. Then you've got 22,500 minus 14,400. Let's subtract 22,500 minus 14,400. Let's check the difference, 8,100. The difference here is 8,100. Now we can determine the length of AM by determining the square root on both sides. Therefore, AM, you determine the positive root of 81, even the positive root of AM squared. Therefore, AM will then be equal to square root 81,000, 8,100, which gives you 90. Therefore, it means AM. Let's go back to the diagram. AM is equal to 90 millimeters. That is the length of AM. Therefore, let me write it nicely. AM is equals to 90 millimeters. Let's check the diagram. We've got AM. This AM is equals to 90 millimeters. The question wants us to calculate the length of AB. Check AB. But we know from one of the theorems that we did that AM is equal to MB. Let's write it down. But AM is equals to MB. It's a geometry. We must provide a reason for that statement. Why do we say AM is equals to MB? The reason is, remember, the perpendicular drawn from the center to the chord bisect the chord. Perpendicular drawn from the center to the chord bisect the chord. And the word bisect means to cut into two equal parts. Therefore, we've got perpendicular drawn from center to chord. The perpendicular drawn from center to chord bisect the chord. What does that mean? It therefore means MB is also equals to 90 millimeters. Here, let me go to the diagram. I mark it. Remember, AM is equals to MB. This side is equals to that one. If AM is 90 millimeters, it means MB is also equals to 90 millimeters. Therefore, it's easy for us to answer the question. What will be the length of AB? 90 plus 90, which will give us 180 millimeters. Therefore, you conclude by saying, therefore, AB is equals to 180 millimeters when you add the two 90 millimeters. Thank you. It was just a brain teaser. It was just a brain teaser to say, let's start first by working on this one. And my approach today mainly is not going to solve the problems for you. For you to understand the solution to a problem, firstly, you need to attempt it on your own. Try to identify where you've got problems. And then thereafter, I'll come up with the explanation, the solution. Then you can check your work out against mine. Because sometimes it does not help to every time come up with a problem and solve it for you. Learners must be able to solve, and for them to realize their weaknesses is for them to work out the solutions. So I'm going to give you a solution, a problem to do on your own, and then after 5 minutes, I will then present the solution. But firstly, I want you to try this one on your own. Check 7.2. I hope it's clear from the screens. 7.2. Then 7.2, the question states, I think it's clear. In the diagram alongside, PR is a chord of the circle with center M and radius R. Remember what I said earlier, you immediately indicate the given information on the diagram. So in the diagram alongside, PR is a chord of the circle with center M, meaning that M is the center. Here is M. M is the center. PR is a chord. PR is a chord very much similar to the problem that we just did. The perpendicular from center M intersects PR at N. Therefore, here's the perpendicular from M is the center. The perpendicular 90 degrees here from center M intersects PR at N. Here it is clearly indicated. PR is 120 units. PR 120, remember what I said earlier, indicate the given information on the diagram. PR is 120 units. QN is 20 units. MN is X units. The first question, write R in terms of X, is for a mark. The second question, calculate the value of R for 5 marks. I want you, grade 12 learners, to do this problem, to solve this one for me in 5 minutes time. After 5 minutes, I will then present the solution to you. But you will then check your work against mine. For now, attempt it, do it on your own. Thank you. I'll carry on the solution in 5 minutes time. Welcome. I hope you got it right. Check your work against mine. Remember the first thing that I said? Indicate the given information on the diagram. In the diagram alongside, PR is a chord of the circle with center M and radius R. R represent the radius, M is the center. PR is 120 units. Check PR. PR, the whole of PR, from here, the whole of PR, 120 units. What does that mean? It therefore means if PR is 120, it means PN will be 60 and NR will then be 60. Why? The perpendicular drawn from the center of the chord bisect the chord. What I said is that PN is equals to NR. Why? The reason, perpendicular drawn from center to chord. Perpendicular drawn from center to chord bisect the chord. Therefore, what does that mean? It means PN is equals to 60 units. PN is 60, NR is 60. We're just indicating the given information on the diagram. QN is 20. What is QN? Check QN. QN, this distance here, is 20 units. And then MN is X. MN is X. Thank you. The first question, 7.2.1. Let's answer that. For 1 mark, write R in terms of X. Write R in terms of X. Check. What does R represent? The radius. And by definition, the radius is the line from the center of the circle to the circumference. So if you can check, MP is the radius. MQ is also the radius, meaning that R will then be equals to X plus 20. Why? MP is equals to MQ, and they are both radii. MP is R, MQ is X plus 20. So if you write R in terms of X, R is equals to X plus 20. The reason is because MP is equals to MQ, and they are both the radii. Thank you. The first question answered. We have expressed R in terms of X. Let's look at 7.2.2. Calculate the value of R. Calculate the value of R. What it means that for us to determine the value of R, we must first determine X. Because once we have the value of X, remember, R is equals to X plus 20. So once we get the value of R, once we get the value of X, it becomes easy for us to determine the length of R, the length of the radius. Let's check from the two diagrams. Let's apply the Pythagoras theorem. Check. MN. In this triangle, in triangle MNP. In that triangle MNP. In triangle MNP. Check what is happening in that triangle. R squared is equals to 60 squared plus X squared. It's a geometry, therefore we must provide a reason for every statement. The reason here is Pythagoras theorem. This is the application of Pythagoras theorem. Let's solve it. Remember R from 7.2.1, R is equals to X plus 20. We substitute, here we've got R, we substitute by X plus 20. Then you square it, which is equals to 60 squared plus X squared. Now let's apply algebra to solve this one. If you expand here, you've got X squared. Multiply here, you've got 40X. You square 20, then it will give you 400. Check 60. You square 60. 60 squared will then give you 3,600. 3,600 plus X squared. Now let's group the like terms. X squared, you transpose to the other side, cancels off. X squared eliminates X squared. So X squared is off. What are we left with? On the right hand side, we'll then be left with 40X. Now we need to transpose 400 to the right. Then you've got 3,600 minus 400, which will give you 3,200. Now, what do we do for us to solve X? You divide by 40. If you divide 40 both sides, you've got 40 will then be equals to, let me check, minus 400. Divide by 40. Thank you. It means you've got 3,200. You divide by 40, therefore X will be equals to 80 units. X will then be equals to 80 units. Let us not forget the question. The question states, calculate the value of R. Calculate the value of R. Calculate the value of R. Now we have got X. X is equals to 80 units. Remember from 7.2.1, R is equals to X plus 20. Remember, but R is equals to X plus 20. This is what we have proved in 1. Proved in 7.2.1. Therefore, we substitute R will then be equals to, you substitute X by 80. You've got 80 units plus 20 units. Therefore, R is equals to 100 units. R is equals to 100 units. I hope you enjoyed it. I did 2 geometric radius, mainly focusing on the application of the Pythagoras theorem, together with the theorem that states the line joining the center of the circle to the midpoint of a chord is perpendicular to the chord, as well as its converse, the perpendicular from the chord, the perpendicular drawn from the center to the chord, bisect the chord. So those are the 2 problems that we have done thus far, and I hope you have learned something, and I hope that even this one, you were able to solve it on your own. Now we carry on with practice of all these other theorems there. Let's carry on. There we are. Look at that problem. Look at the problem. Thank you. 7.2. 7.2, this one. In the diagram alongside, O is the center of the circle ABDC. O is the center of the circle ABDC. What does that mean? It means point A, point B, point D, point C lie on the circumference of the circle. Then we say they are concyclic. They lie on the circumference of the circle, meaning that they are concyclic. O is joined to B and C. O is the center. Now you join O to B and O to C. Therefore, you've got OB as the radius, OC as the radius. And you know the radii of the same circle are equal in length. Angle OBX. Check OBX. It's clearly marked on the diagram. OBX. OBC, I'm sorry. Angle OBC is equals to X. Angle OBC is equals to the X. Sorry for that. The first question, determine with reasons the following angles in terms of X. The first one, you determine O1 in terms of X. Second one, determine angle A in terms of X. Last one, 7.2.3, you determine angle D in terms of X. 2, 4, 6 marks. I think this 6 marks, you can finish it off in 4 minutes time. I'm going to give you 4 minutes to try this one on your own. Remember the key, indicate the given information in the diagram, and then you apply your theorems. Good luck. I'll continue with the solution to this problem after 4 minutes. Carry on now. Welcome, welcome. Check your work against mine. Check your work against mine. Thank you. In the diagram alongside, O is the center of the circle ABDC. O is joined to B and C. O is joined to B and C. What does that mean? It means OB is equals to OC because those are the radii of the same circle. Angle OBC is equals to X. It's marked X. This angle here is marked X. So the first question, determine with reasons the following angles in terms of X. Let's start with O1. Here is O1. 7.2.1. Statement number 1. Angle C1 is also equals to X. Why do I say angle C1 is equals to this X? Why do I say this angle C1 is equals to X? The reason is that OB is equals to OC, and those are the radii of the same circle. What does that mean? It means this angle here is also X. So it becomes easy for us to determine O1 in terms of X, because this angle, O1, plus X, plus C1, they all give us 180 degrees. Those are the angles of a triangle. We know angles of a triangle add up to 180 degrees. Interior angles of a triangle. Angles of a triangle. Interior angles of a triangle, they add up to 180. Therefore, we've got O1 plus X. Remember, C1 is also equals to X is equals to 180 degrees. Then you make O1. We make O1 the subject of the formula. Angle O1 will then be equals to 180 degrees minus X plus X gives 2x, and then transpose to the right, then it goes minus 2x. Then that will be the size of angle O1. 7.2.1, 7.2.1. 01 will then be equal to 180 degrees minus 2x, because the question states determine with reasons the following angles in terms of x. So 01 in terms of x will then be equals to 180 degrees minus 2x. I hope you enjoyed that one. Second one, let's determine angle A in terms of x. Numbering is key. 7.2.2. We want to determine angle A in terms of x. Remember, from the given statement, O is the center of the circle. So if O is the center of the circle, we then say O1 is equal to twice angle A. Remember, there is a theorem that states the angle which an arc of a circle subtends at center is twice the angle it subtends on the circumference of the circle. So you write down the reason. Angle at center is equal to 2 times angle at the circumference of the circle. Angle at center is equal to twice angle at the circumference of the circle. Check O1. Remember, angle O1, we are from 7.2.1. O1 is equal to 180 degrees minus 2x. Now we substitute it here. We substitute O1 by 180 degrees minus 2x, which will then give you 2 times angle A. So to determine angle A, you divide by 2 both sides. Let's divide by 2. If you divide by 2 here, you've got angle A here. You divide by 2 here, it's 90 degrees. You divide by 2 there, it's x. Now we're done. We've got the value of angle A in terms of x. Therefore, in terms of x, angle A is equal to 90 degrees minus x. That was 7.2.2. I hope you also got it right. I hope you also got it right. Thank you. Let's check the last one. 7.2.3. 7.2.3, angle D. Determine with reasons the size of angle D in terms of x. Where is angle D? Here it is. Thank you. Let's answer 7.2.3 and see how it goes. 7.2.3. If you look at the diagram, check angle A, check angle D. How do they relate? Because A, B, D, C are points on the circumference of the circle. Therefore, it means A, B, D, C is a cyclic quad. It's a cyclic quad. As a result, angle A plus angle D must give you 180 degrees. Those are the opposite angles of a cyclic quad. There is a theorem relating to cyclic quad which states opposite angles of a cyclic quad are supplementary. That's why we say angle A plus angle D is equal to 180 degrees. Those are the opposite angles of a cyclic quad. We said angle A plus angle D gives us 180 degrees. These are the opposite angles of cyclic quad. Those are the opposite angles of cyclic quad. Opposite angle of cyclic quadrilateral. Angle A from 7.2.2, angle A is equal to 90 degrees minus x. So we substitute angle A here by 90 degrees minus x plus angle D. They will give us 180 degrees. Now it's easy for us to determine the magnitude or the size of angle D. Transpose 90 to the right. 180 degrees minus 90 will give you 90 degrees. This is x. You transpose it to the right. It becomes positive x. Therefore, it means angle D will then be equal to 90 degrees plus x. I hope you enjoyed this one. I hope you got it right. Remember, the objectives for today's lesson is to revise Euclidean geometry. All those riders, come up with solution to the riders, because we believe practice makes perfect. If you do lots and lots of exercises relating to the solution of solving geometric riders, then even in the exam, they will become easy. Thank you very much. I think should give you we should do one more exercise before we go for a break. One more exercise before we go for a break. Check this one, the last one. It's question 8. I hope it's clear on your screens. In the diagram, ST parallel to QW, and PQR is a tangent to the circle. PQR, check, it's given. ST parallel to QW, and they are indicated. Thank you. And PQR is a tangent to the circle QSTVW. QSTVW. That clearly indicates that those points lie on the circumference of the circle. Then W1 is equal to 70 degrees. Where is W1? The given information. Here is this angle. You indicate the given information on the diagram. This angle is 70 degrees. It's given. And Q3, what is Q3? This Q, here is angle Q3. This Q3 is equal to 30 degrees. Indicate the given information on the diagram, if it's not indicated. Now that it's we have indicated it, let's answer the questions then. The first question, calculate with reasons the magnitude of the following angles. Angle V, here is angle V. You need to determine the size of angle V. Q1, you need to determine the size of Q1, Q2, and T1. And there is angle T1. 2 is 3 marks, it's 5 marks, it's a mark, it's another 2 marks. All in all, this question takes about 3, 6, 8 marks. So I'll be happy if I can give you 5 minutes to work on this one. And then after 5 minutes, I'll then carry you through to the solution so that we can then have a break. And then after a break, we'll then carry on with the grade 12 geometry. For now, for the next 5 minutes, find the solution to this one. Thank you very much. Welcome. Let's determine the solution to this one. Thank you. Remember the given statement. In the diagram alongside, ST is parallel to QW, and they are marked. ST parallel to QW. The two parallel lines are marked. And PQR is a tangent. PQR is a tangent. Angle W1 is 70 degrees. We have marked it. Q3 is equal to 30 degrees. We have marked it. The first question, calculate the size of angle V. Look at the diagram. Look at the angles that relates to angle V. Especially try to look at the angles that we know their values, their magnitude, their sizes, and then we try and relate them to angle V. If you can check, angle V is related to angle S1 because TSWV is a cyclic quad. I repeat, TSWV is a cyclic quad. So if TSW is a cyclic quad, it means opposite angles are supplementary. But we don't know the size of angle S1. Let's determine S1 first. 8.1.1. 8.1.1, check S1, check W1. We say S1 is equals to 70 degrees. Why do I say this angle was that angle? Because we've got parallel lines. We know once we have parallel lines, alternating angles will then be equal. Therefore, S1 is equal to W1, which is 70 degrees. The reason is that TS is parallel to QW. Therefore, those are the alternate angles. Alternate angles where TS is parallel to QW. So it means S1 here, we've got 70 degrees. Now we can relate S1 to V by saying angle S1 plus angle V, they give us 180 degrees. Let's provide the reason for that statement, because these are the opposite angles of cyclic quad. These are the opposite angles of cyclic quad. The opposite angles of a cyclic quad. Let's substitute. S1 is 70 degrees plus angle V, then you've got 180 degrees. Therefore, it means our angle V will be equal to 180 degrees minus 70, which will give us 110 degrees. We are done with the value of V. Therefore, it means V here we've got 110 degrees. Hope you are happy with the solution to the first one for 3 marks. I hope you are happy with the solution for the first one. Check the second one, Q1. 8.1.2, determine Q1. Where is Q1? Here is Q1. How can we relate Q1 to any of the angles that we know? Check Q1. Remember, PQR is a tangent. If PQR is a tangent, Q1 becomes an angle between a tangent and a chord, and W1 becomes an angle in the alternate segment. Meaning that for us to determine to find the solution for 8.1.2, 8.1.2, the solution will then be Q1 is equals to W1. Q1 is equal to W1. This is tan chord theorem, according to tan chord theorem. Therefore, it is also equals to 70 degrees. This is according to tan chord theorem. Tan chord theorem. The angle between a tangent to the circle and a chord drawn from the point of contact, that angle is equal to angle in the alternate segment. So Q1, where is it? Here is Q1. We've got Q1 here as 70 degrees as well. 8.1.2 answered. 8.1.3, we are required to call it Q2. Remember, PQR is a tangent. A tangent is a straight line that touches the circle at one point only. So let's calculate Q2. 8.1.3. If you look at the diagram, angle Q1 plus Q2 plus Q3, they give us 180 degrees because PQR is a straight line. PQR is a straight line. Let's go. It means check angle Q1. We said Q1 plus Q2 plus Q3, all these angles add up to 180 degrees. Those are the angles on straight line. And angles on a straight line add up to 180 degrees. Remember, Q1 is 70 degrees. We want to calculate the size of Q2, and Q3 is equal to 30 degrees. It is given. It is given. So all we have to do is to transpose 70 and 30 to the right. 70 plus 30 gives you 100. So on the left-hand side, we want to be left with Q2 only. So 70 plus 30, 100, transpose it to the right. Then we have 180 degrees minus 100 degrees, which will give you 80 degrees. Then we are done with the value of Q2. I hope you enjoyed that one as well, 8.1.3. Let's check the last one, T1. T1, where is T1? Here is T1. Look at any angle that relates to T1. Any angle that relates to T1, especially the angles that you know their sizes, the angles that you know their magnitudes. So already remember, we said Q2 here, we had 80 degrees. We've got 80 degrees. So immediately, T1 and Q2, they relate because TSQ TSQW. TSQW is a cyclic quad. It's a cyclic quad. As a result, the opposite angles are supplementary. Then it means this 80 degrees plus T1, they should give us 180 degrees. They should give us 180 degrees. Those are the opposite angles of a cyclic quad. Let's solve 8.1.4. 8.1.4, we said 1 to T1, angle T1 plus 80 degrees. They give us 180 degrees. T1 plus 80, let's check. T1 plus this 80 of Q2. T1 plus this 80 of Q2, they give us 180 degrees. Those are the opposite angles of a cyclic quad. Let's write the reason opposite angles of cyclic quad. Now we can solve T1. Therefore, T1 will then be equal to 180 degrees minus 80, which will give you 100 degrees. Thank you very much. I hope you have enjoyed the few exercises that we did together. I'm going to give you a 5 minutes break just to refresh a bit, and then after 5 minutes we'll then continue with more exercises on Euclidean geometry. But the more focus will now be on those grade 12 theorems, similarity theorem and the proportionality theorem. For now, I thank you. Welcome again for the second session, which will be a bit short because we'll be knocking off at 2:30 and we are left with about 25 minutes. So I want to take you some few geometric riders relating to grade 12, proportionality and similarity theorems. Thank you. Check the exercise that I'm going to do with you right now. 7.2. Look at the exercise. In the diagram below, triangle VRK, check triangle VRK. Has P on VR, and T on VK, such that PT is parallel to RK. All the information clearly marked. VT is equal to 4 units. Here's VT is 4. PR is 9. PR is 9 units. TK is 6. TK is 6 units. And VP is equal to 2x minus 10 units. The first question, calculate the value of x. Calculate the value of x. Maybe I should take you through this one because I'm just welcoming you into grade 12. Into grade 12's work. So, proportionality theorem. Remember, the proportionality theorem states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Let's check the solution for 7.2. VP over PR. I'm saying VP over PR. This will then be equals to VT over TK. VT over TK. Let's write down a reason for that statement. It's because it's a line parallel to a side of triangle. A line parallel to a side of a triangle. We know that a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Let's check VP. VP is 2x minus 10. Then we've got 2x minus 10 over PR is 9, which is equals to, check VT is 4 over TK is 6. Let's cross multiply. If we do the cross multiplication here, or we can simplify 4 divided by 6 here, we've got 2x minus 10 all over 9. This is the same as 2 over 3 because 2 is a common factor. Even here in 6, 2 goes 3 times. We can cross multiply. If we cross multiply, you've got 3 multiplied by x will give you 6x. 3 multiplied by 10 will give you minus 30. Then 9 multiplied by that 2 gives you positive 18. If we cross multiply here, 9 by 2, 18. 3 multiply this, 2x gives you 6x. 3 multiplied by 10 gives you 30. Now, let's group the like terms. On the left-hand side, we are only left with 6x. We transpose this negative 30 to the right. Then we've got 18 plus 30, which will give you 48. Now it becomes easy for us to solve for x, because if we solve for x, we just divide by 6 both sides, and then we find that 48 divided by 6, then it will give you 8. Therefore, it means x is equals to 8 units. Then calculate the value of x. Therefore, here x is equals to 8 units. The only theorem that we applied here is the grade 12 theorem, which states a line parallel to a side of a triangle divides the other two sides in the same proportion. From there, we just carried on with the algebraic manipulation. That's why we got the value of x as 8. It wasn't difficult, and I hope you enjoyed it. So I'm going to give you an exercise based on the very same theorem. I want you to do it in 5 minutes time. I'm going to give you 5 minutes to do a similar problem. Thank you. There we are. It's question 10 of 2011. Thank you. There we are. In the figure below, DE parallel to FG, parallel to BC, AD 36 centimeters, DF 24 centimeters, AE is equal to 48 centimeters, and the DE is equal to GC, and they are both equal to 40 centimeters. The question then states, determine with reasons the length of 10.1 EG for 2 marks. You need to determine the length of EG for 2 marks, and then determine the length of BC for 4 marks. I'm going to give you 5 minutes to work it out. And then after 5 minutes, I will then do it for you so that you can then check your work against mine. I hope you enjoyed this one and you also got it right. Good luck. Welcome, welcome, welcome everyone. Welcome everyone. I think you've enjoyed the first one. Now this is the second one on grade 12. The theorem, the proportionality theorem. Let's check. In the figure below, DE parallel to FG parallel to BC. All the information clearly indicated on the diagram. AD is 36, here is 36. DF 24, here is DF 24. AE is 48, here is AE 48. DE, whereas DE 40 and GC 40. So the first question then states for 2 marks, determine with the reasons the length of EG. The length of EG. Let's apply the theorem. Here is EG. Can I do this? You'll allow me to do this? I believe. There we are. There we are. Now you can see if I do that, we have triangle AFD where DE is parallel to FG. And we know that a line parallel to a side of a triangle divides the other two sides in the same proportion. Let's carry on. The question states EG. We want EG. Here is EG. You can say EG over 48. EG over 48 will then equal to 24 over 36. 24 over 36. Then you write down the reason for your statement. It's Euclidean geometry. Every statement must be accompanied by a reason. The reason here is a line parallel to a side of a triangle. A line parallel to a side of triangle. We know that a line parallel to a side of a triangle divides the other two sides in the same proportion. Then we just do our algebraic manipulation here to determine the length of EG. Therefore, you multiply both sides by 48. Therefore, EG will then be equal to, you multiply by 48 here, you've got EG, you multiply this one by 48. Let's check the answer. You work out the answer, 24, you divide it by 36. Then the answer you multiply by 48. I think the answer you get is 32. EG will then be equal to 32 centimeters. 32 centimeters. Now we go to EG. This EG is equals to 32 centimeters. It is key, it is very much important to always indicate the given information on the diagram. Happy with 10.1? This was 10.1. Now let's look at 10.2. 10.2 then states, let's find the length of BC. 10.2, we are required to calculate the length of BC. Let's carry on. How can we determine the length of BC? Remember, in grade 12 again, we have what we call the similarity theorem. Let me take two triangles. Check this bigger triangle, triangle ABC. I want us to work with those two triangles. Then I say in triangle ABC and triangle ADE. Look inside the two triangles. Triangle ABC and triangle ADE. I want us to prove similarity between the two triangles, this bigger triangle and the smaller triangle. And you know very well, to prove similarity between any two triangles, you just have to prove that two pairs of angles to be equal, and then the third pair, because they'll add up to 180 degrees, will automatically be equal. Thank you. We are busy with 10.2. This is 10.2. We are in triangle ABC and triangle ADE. In the two triangles, check. We've got angle A. This angle appears in triangle ADE. And again, this angle A appears in triangle ABC. So we say angle A is equals to angle A. It's common. It is common to the two triangles. Then, in triangle ABC, check angle B here. Angle B. Check angle B here. Because this BC is parallel to DE. If I can simplify it, I can also say I've got D1 here and E1 there. Check the relationship between angle B and angle D1. Then I will say angle B is equals to angle D1. Those are the corresponding angles. Corresponding angles where DE is parallel to BC. See? Already we've got two pairs of angles. Check the remaining pair. In this two triangle, in triangle ABC, I've talked of angle A and angle B. The remaining angle here is C. In triangle ADC, I've talked of angle A and I've talked of angle D1. I haven't talked of angle E1. So it means angle C will be equal to E1 as well. Angle C will also be equal to angle E1. Why do I say they are equal? Because these are also the corresponding angles. Because those are also the corresponding angles where DE is parallel to BC. Therefore, it means the two triangles are equiangular. And if they are equiangular, then it means the two triangles are similar. Then we draw a conclusion that, triangle ABC will then be similar to triangle ADE. ADE. There is an angle. It's a geometry. We always provide a reason for our statement. I'm sorry for this lovely work, but here triangle ABC is similar to triangle ADE because we have proven above that the two triangles are equiangular. Angle. So if two triangles are equiangular, it means their corresponding sides are proportional. This is strictly grade 12 swag. Let's check. And you try to choose the sides that you know or the side that you want. Check BC here. We want this side BC. This is the side we are looking for, BC. Then you say BC over, if you take BC here you'll have to take AD. AD. BC over AD will then be equal to, remember, if two triangles are similar, then their corresponding sides are proportional. Now we have proven that the two triangles are similar. Now I'm taking their sides proportionally, meaning that BC over AD will then be equals to, let's check what we have. Again, AE we know AE, we know A, here is AE we know, we also know AC. Therefore, you can say AC, in this side you take AC. If you take AC, you'll take AE here over AE. Because the two triangles are similar. If they are similar, it means their corresponding sides are proportional. Now we want to answer 10.2 to determine the length of BC. Let's check. BC over, check AD. Check AD. What is AD? AD is 36, which is equals to AC. Check AC. AC, it means you've got to add 40 plus 32 plus 48. Let's add them together. 40 plus 32 plus 48. They all give us 120. Then they give us 120 over AE. Check AE is 48. Now we multiply both sides by 36. If you multiply by 36 here, you'll be left with BC. You multiply that fraction by 36, you've got 120 divided by 48. Then the answer you multiply by 36. Multiply both sides by 36. You've got BC as 90 units. Therefore, BC is equals to 90 centimeters because the units that we are using here are centimeters. So BC will be equal to 90 centimeters. Thank you very much. I hope you enjoyed this one. I think time is almost up. I had a question. I want to respond to the question. One of the viewers asked me to give him or her an outline of the paper. How will paper 2 look like at the end of the year? Unfortunately, because of time, I am unable to break it down properly because it will take me more time. But I'm sure that in yesterday's presentation, Mr. Moswani clearly outlined how the paper 2 will look like. And again, just to add on that, if at school, all the schools have been provided with the exemplar papers, please ask your teacher to give you an exemplar paper for grade 12, paper 2. Then the end of the year paper will be more or less similar to the exemplar. That's why I'm saying, for me to break it down right now, it will take me a lot of time, and I don't think we have that time available at the moment. You can again view yesterday's presentation by Mr. Moswani, where he outlined how the paper 2 will look like, or alternatively, ask your teacher to give you an exemplar paper, and that if the teacher can give you that exemplar paper, you will then have an idea, because the exemplar paper is a paper that indicates more or less how the end of the year paper will look like. But all I can say in paper 2 is that the section that I'm doing right now, which is Euclidean geometry, will only take 50 marks. Paper 2 will be out of 150. This Euclidean geometry will take 50 marks. We've got trigonometry, which will take 40 marks. We've got analytical geometry, which will also take 40 marks. And then statistics will only take 20 marks. And that is all clearly indicated in yesterday's presentation by Mr. Moswani. And even the exemplar papers confirms that. I hope I have tried my best to answer that question. Thank you. Let's carry on. I think we are left with about 5 minutes. And this remaining 5 minutes, I can take you to one more problem. We can do one more problem relating to this grade 12 proportionality and similarity theorems. Let me take you through this one problem, and then we can call it a day for today. We'll Then continue again tomorrow. Check. Let me do this one with you. Let's do this one together for the remaining 5 minutes. Okay, right. It reads, AB is a diameter of the circle ABCD. AB is a diameter of the circle ABCD. It means A, B, C, and D are concyclic. They lie on the circumference of the circle. And you know, once they say AB is a diameter, automatically you know an angle subtended by diameter is 90 degrees. And you immediately mark 90 degrees there, because angle C is subtended by AB. Therefore, it means angle C will then be equal to 90 degrees. OD is drawn parallel to BC. Look at OD. It is drawn parallel to BC. And if OD is parallel to BC, the corresponding angles will then be equal. We cannot talk of the alternating angles here, but we can talk of the corresponding angles. Therefore, immediately you mark here 90 degrees. E1 can mark this one angle E1 to be equal to 90 degrees, because E1 corresponds with C. Thank you. If the radius, let's check the radius. If the radius is 10 centimeters, what is the radius? Distance from the center to circumference. OA is 10. You've got 10 here. It's 10 centimeters. If the radius is 10 centimeters, AC, where is AC? This AC, the whole of AC is 16 centimeters. Remember, I said it's 90 degrees here. If AC is 16, then you know that this one will also be 8. AE will be 8. EC will also be 8. Because you know, the perpendicular drawn from the center to the chord bisect the chord. The perpendicular drawn from the center to the chord bisect the chord. We call this line the perpendicular because E1 is 90 degrees. And it is from the center because O is the center. So we say perpendicular drawn from the center to the chord bisect the chord. Calculate the length of ED. Now the question is to calculate the length of ED. Let's do it together in the remaining few minutes. Now our workout. Firstly, remember we are answering question 9. Angle C is equals to 90 degrees. All the information that you indicated earlier, now we need to write it down now so that it can be allocated marks. This carries for 5 marks. We need to, all the information that we indicated earlier, we have to indicate, we write it down. Angle C is equals to 90 degrees. This is an angle subtended by diameter. We know the angle subtended by diameter is equals to 90 degrees, or we can say angle in a semicircle. Angle C is equals to 90 degrees, angle subtended by diameter. Then we say, we mark off D1 here. Say angle D1 is equals to angle C as well. D1 is equals to 90 degrees. Why? Because those are the corresponding angles where OD is parallel to BC. Now, remember what is given. We are given that AC is 16. AC is 16 centimeters. So we need to provide the reason why do we say AE is equals to EC. Now we say AE is equals to EC and each is equals to 8 centimeters. Why? Perpendicular drawn. You can say perpendicular drawn from center to chord. Sometimes if you forget, you can just say OE perpendicular to AC. So it's 8 centimeters. Now we can apply Pythagoras theorem to determine the length of OE. Because once we can get OE and OD will be then be equals to OA, because those are the radii. Okay? According to Pythagoras theorem, 10 squared is equals to 8 squared plus OE squared. Now, let's check 10 squared, you've got 100. 8 squared gives you 64 plus OE squared. Now you transpose. You are left with OE on the right-hand side, OE squared. 64 you transpose to the left, 100 minus 64, you're left with 36. Then you determine the square root both sides. Therefore, OE will then be equals to 6 centimeters. 6 centimeters. Here is OE. OE will then be equals to 6 centimeters. But remember, OA is the radius. OD is the radius. Therefore, we say OA, but OA is equals to, this OA is equals to OD. Why do I say they are equal? Because those are the radii of the same circle. Now OA is 10. Check OD. OD is 6 plus ED. This OE plus ED, and OE is 6. It's going to be 6 plus ED. Then we've got 6 plus ED. Therefore, it means ED, you transpose, ED will be 10 minus 6, which will give you 4 centimeters. 4 centimeters. Therefore, when answering this question, it means ED will then be equal to 4 centimeters. Thank you very much. I think I've arrived at the end of the session, and I hope you find the session inspiring. Please, I always say this when I'm here at the IBP, practice makes perfect. Keep on practicing. If you practice, the theorems will just come automatically to you, and you won't encounter problems at the end of the year. Let me take this opportunity again to wish you well in your examinations. I know some of you are in camp, some are studying very hard, working hard at the school, final preparations because exams are starting on this coming Monday. Let me wish you well and keep on working hard. Thank you very much.